Hello everyone, welcome back to my YouTube channel. My name is Arnav Jain and I'm currently working as an SDE toward Amazon. And today we're going to talk about one of the most important creational design patterns, the abstract factory design pattern. So far, we've already covered all the solid principles and we've also discussed the factory method pattern. Now it's time to take it one step further and understand abstract factory. And before we begin, if you haven't already, please make sure to like and subscribe to the channel. It really motivates me to keep creating more such content for you. Alright, let's get started. Imagine you are building a furniture shop simulator. In your system, you have different types of products: chairs, sofas, and tables. Each of these products can come in different styles. For example, you might have a modern style, a Victorian style, or maybe even an Art Deco style. Now, here's the important part. In this system, our clients don't just want individual items like a chair, sofa, or coffee table. Instead, they want complete catalogs, where each catalog represents a family of related furniture items. For example, if a client selects a modern catalog, they should get a modern chair, a modern sofa, and a modern coffee table. Similarly, if they choose a Victorian catalog, all the products should follow the same Victorian design. And this grouping of related products is what we call a product family. But here's the challenge. How do we design a system where we can create families of related objects, ensure that all selected products belong to the same style, and still keep our code flexible enough to add new catalogs in the future without modifying existing code? This is exactly where the abstract factory pattern comes into the picture. Now, there are multiple steps to solve this problem, so make sure you follow till the end. Let's start with step 1. First, we create interfaces for all product types. In our example, that means a chair interface, a sofa interface, a table interface. These interfaces define what each product should do without worrying about how they are implemented. Next, for every style, we create concrete implementations of these interfaces. So for styles like modern Victorian Art Deco, we create implementations like modern chair, Victorian chair, Art Deco chair. And similarly, we create corresponding implementations for sofas and tables as well. Now, what's the benefit of this? If in the future you want to add a new style, you simply create new implementations for each product interface. No existing code needs to change. This makes your system easily extendable and scalable. And that's our step 1. Now let's look at the code. First, I created an interface called chair. Inside this interface, we have two methods: has legs and sit on. These methods are only declared here, not implemented. So to actually use them, we need concrete classes that implement this interface. Now, we have three types of chairs: modern, Victorian, and Art Deco. So I created three classes: modern chair, Victorian chair, and Art Deco chair. Each of these classes implements the chair interface. For example, in modern chair, the has legs method prints that the modern chair has sleek legs, and the sit on method prints sitting on the modern chair. And similarly, for Victorian chair and Art Deco chair, the structure remains the same. The only thing that changes is the message being printed. Now, moving on to sofa. I created a sofa interface with two methods: has cushion and sit on. Again, these are just method declarations. Then I created three implementations: modern sofa, Victorian sofa, and Art Deco sofa. Each of them implements the sofa interface, and just like before, the only difference between them is the output message. Next, I created the table interface. Here we have two methods: has legs and place items. And again, three implementations: modern table, Victorian table, and Art Deco table. All these classes implement the table interface, and the only variation is in the printed statements. So with this, our first step is complete. We have defined all product interfaces and their concrete implementations. Now, to execute this code, we update the main method. Here, I create a chair object using modern chair, a sofa object using Victorian sofa, and a table object using Art Deco table. Then I call their respective methods. When we run the program, we get outputs corresponding to each specific implementation. Now, one important thing to notice here is that we are directly instantiating concrete classes like modern chair or Victorian sofa. But ideally, we don't want the client to deal with these concrete classes directly. Instead, the client should only specify what type of furniture they want, whether it's modern, Victorian, or Art Deco. And based on that input, we should provide a complete set of related objects, that is, the chair, sofa, and table, all belonging to the same family. With further steps, we'll be able to accomplish that. Now let's move to step 2. In this step, we create an abstract factory. This is simply an interface that defines how a group of related objects should be created. Now let's create the code for this abstract factory. We create an interface called Furniture Factory. Inside this interface, we define three methods: create chair, create sofa, and create table. Each method returns an interface type. Chair, sofa, and table are all interfaces. So this abstract factory only defines what objects will be created, not how they are created. So with this, we have completed step 2. Now let's move to step 3. In this step, we create implementations of the abstract factory interface. Since we have three styles, we will create three factory classes. Now let's move to the code to understand this in more detail. Here, I have created three classes. Each of these classes implements the furniture factory interface. Inside these classes, we implement all three methods: create chair, create sofa, and create table. The only difference is that each factory returns objects of its own style. Modern Furniture Factory returns modern chair, modern sofa, and modern table. So each factory ensures that all the objects it creates belong to the same style. Now, if you look at the main class, which is the client, if the client wants to create modern furniture, it simply assigns the furniture factory reference to modern furniture factory. After that, the client just calls the methods like create chair, create sofa, and create table to get the required objects. And when we execute the code, we get the chair, sofa, and table of the modern type. With this, we are able to implement the abstract factory pattern. Now let's understand the UML diagram. First, we create interfaces for all the products. Second, we create concrete implementations of these products. Third, we create the abstract factory interface. Fourth, we create concrete factory classes based on different styles. Finally, the client uses these concrete factories through the abstract factory interface to create objects. Simple. Please note, don't get confused about whether you should create an interface or an abstract class. It totally depends on your use case, and both approaches are valid. If you're not familiar with interfaces or abstract classes, please watch my previous videos. With this, we have completed the abstract factory design pattern. Thank you for watching the video. If you liked it, please like and subscribe to the channel. See you in the next video, where we will cover more creational design patterns.